Very good morning to one and all present here. I am Professor Ashwadip Kulwini, Assistant Professor in the Department of Mechanical Engineering. Welcomes you all for today's lecture of Advanced Manufacturing Techniques, an elective subject of 8th semester Mechanical Engineering. My dear friends, in our previous video, we started discussing about the non-conventional machining process. Then we were discussing about water jet machining process and other associated processes. Other associated process, that it means the machining processes having the working principle similar to that of water jet machining, and those machining processes are abrasive water jet machining and simply abrasive jet machining. In previous lecture we have seen its introduction parameter system, their detailed components. With the help of this diagrammatical representation, we have seen the construction feature of water jet machining processes, wherein we can observe several parts and components like fluid supply, pump set with intensifier, accumulator, control valves with the hydraulic unit, and nozzle. In the end, there will be a drain that will act as a reservoir for the fluid. The hydraulic pump, it is used to flow the water or fluid from the reservoir. With increased in kinetic energy, the intensifier is utilized. It is used to raise the pressure from 4 to 3800 bar, right? That is the role of intensifier. Accumulator is utilized to eliminate the pulsation occurring in the pipe. As we all are aware that in the flow through pipe, two, two main types of losses occur, and these two are major and minor losses. We must take those losses into consideration and we must eliminate for successful operation of water jet machining. The high pressure tubing, generally the tubings and the piping system in this process are somewhat different than that of the normal tubing or normal pipings, as it is carrying high energy, high pressure fluid, right? And we must also take into consideration the losses from flow through pipes, right? For that purpose we are using the high pressure tubing ranging from 6 to 14 mm in diameter. Towards the jet cutting nozzle, this will play a vital role as we are using high pressure water, and in order to further increase it with the high energy, high kinetic energy and the pressure, the jet or the nozzle will play a vital role, right? To maintain the diameter from 0.1 to 0.3 mm, the nozzle will play a vital role, and generally the nozzle will also get eroded from the high pressure of water or fluid coming out of it. So generally it is utilized and its use is restricted to around 200 hours of its operation. So the nozzle provides a coherent water jet stream from optimum cutting to low density soft material that is considered unmachinable by conventional methods. Nozzles are normally made from synthetic sapphires, which is a harder material, right? At around 200 hours of operation are expected from a nozzle, which becomes damaged by particles of dirt and the accumulation of mineral deposits on the internal periphery of the orifice due to erosive of water hardness. Right? Generally, if filtration doesn't happen successfully, even though a single particle of dust and dirt will it may damage the nozzle. A longer nozzle life can be obtained through multi-stage filtration, which removes the undesired solids of size greater than 0.45 micrometer. Now coming towards the catcher. The catcher is nothing but a reservoir. When the cutting is happening, it is usually kept on the fixture wherein the stream of jet, stream of water jet will cut or perform drilling operation, but after cutting or drilling, it should strike at the bottom section of the tank or the catcher. So it is made accordingly, and apart from that, in order to reduce its noise, moreover, it reduces the noise level from 105 decibels associated with the reduction in the velocity of the water jet from Mach number 3 to subsonic level. Right? As high intensified jet is coming out of the nozzle, it will certainly raise the sound intensity, and in order to minimize it, the catcher will play vital. The material removal rate, surface quality, and the accuracy. The flow chart is representing the performance, right? The jet nozzle having its diameter, standoff distance, isn't it? Its working duration. Generally, if the water condition is okay, if it is filtered properly, then it will work for around 200 hours. Other parameter like workpiece, its type, thickness, its feed rate will also matter. The jet fluid, apart from water, what kind of fluid we are utilizing here, its velocity, flow rate, pressure, and velocity. Collectively, those parameters will play vital role in the successful uh, performance of water jet machining. Right. Here, another detailed parameter is shown here, wherein I would like to focus on to the standoff distance. Right, the standoff distance is nothing but the distance between the nozzle and the workpiece. Right. For the successful machining operation, we are keeping the diameter of the water jet, fluid jet at in the range of 0.1 to 0.3 mm, and a standard standoff distance is ranging from 2.5 to 6 mm. However, for material used in the printed circuit boards, it may be increased to 13 to 19 mm. Circuit boards is nothing but the motherboards that we use in computers, laptops, and the TVs, wherein we will observe very fine holes are there to mount very fine chips, right? But larger this kind of distance, smaller would be the depth of cut. Yes, of course, and this will depend upon the thickness of material to be removed and the type of material also, right? When cutting fiber reinforced plastics, reports showed that the increase in machining rate and use of the smaller nozzle diameter increase the width of the damage level. Okay, so while performing machining or cutting drilling operation over the plastic material, you must keep certain precautionary measures. Now the jet fluid, a typical at around 150 to 2000 megapascal is maintained to provide 8 to 80 kilowatt of power. For a given nozzle diameter, increase in pressure allows more power to be used in the machining process, which in turn increases the depth of cut. Jet velocity ranging from 550 to 1400 meter per second. Generally, it is kept at around 900 meter per second. The quality of cutting improves at higher pressures by widening the diameter of jet and by lowering the traverse speed. Under such conditions, materials of greater thickness and densities can also be machined. Jet fluids, moreover, the larger the pump pressure, the greater will be the depth of cut. Fluid used must possess low viscosity to minimize the energy loss and should not be corrosive, isn't it? As most of the metals are ferrous metals, it should not be corrosive one and should not be toxic. Water is commonly used for cutting alloy steels, and more versatile materials can also be machined with the help of jet fluid. Now, table is representing material, the thickness, and the feed rate. The thickness is representing how thick material that we can cut with the help of the stream of jet, the stream jet of water. Brittle materials will fracture, of course, while ductile ones will cut well. But if we could maintain this kind of distance in between the ceramics and other brittle materials, we can get a successful cut or drill over its surface. Right? The material thicknesses ranging from 0.8 to 25 mm or more can be machined. The table is representing cutting rates for different material thickness. Few of them I would like to mention here are leather, vinyl chloride, polyester, Kevlar, graphite, gypsum, corrugated boards, pulp sheet, plywood. Right? Apart from sheet metal, we can cut almost all the metals, all the materials. But again, one precautionary measure that the use of fluid, whether we are using oil or we are using water, right? And their respective feed rate is mentioned here. Of course, their application, wide range of applications are there of water jet machining process. Few of them I would like to mention here as it is used on metals, paper, clothes, leather, rubber, plastics, food items, and over ceramics also. Both cutting as well as drilling can with the help of this process. Surface treatment for etching of the surface, right? For etching we can use water jet machining here. Today we will the next lecture we will be discussing about the abrasive water jet machining, and lastly the abrasive jet machine. Thank you for your patience listening and valuable time. Thank you so much.